So, I said I was going to work on hardware today, but I'm not going to work on hardware today. Sorry. What I have decided is, firstly, let me see if I can. Well, I certainly can bring up this link that was shared with me. Firstly, I should mention actually I was bearing a bit of the lead. Sysgen's still just here. I haven't touched this since yesterday, so anyway, we're ignoring that for now. We might have to do more fun, different things to get DOS 65 working. Good evening, Wereworm. Oh, also as a general heads up, this is a tabletop night, so I have to bust out of here at 6:30 EST, and it is 5:13 right now. So let's get as much into an hour and 15 as we can. Anyhow, so what I'm thinking is let's work on some software stuff, actually clean things up, because it's been needing that for a while, or at least clean things up as much as possible. What I would like to do is start by at least implementing a read an arbitrary sector command, because right now we have a read sector command, but it just always reads from sector 0, so we should update that. But before we do that, like I was saying, the reason I'm delaying is because, let me get my Discord up here, and hopefully try not to share any secret information. Yeah, I said, we're going to be doing dev cart rejiggering today. That is not true. Let's see. Oh, Halion was excited about that. No, because I think this was actually, yeah, this was Halion's fault, is why we're not doing this. Because it didn't even occur to me until I bought this prototyping cart. Right, I would have to cut traces on the Super Mario PCB, not just solder to the contacts. I would have to cut traces so that the MMC3 doesn't activate and select the stuff that's on the board and subsequently cause us bus contention and stuff. So yeah, I'm just gonna, this thing is ordered. I am just waiting on it. I am hoping that, oh yes. So this is almost certainly NES, not Famicom. There was some worry about that, but no, it is. I ordered cases. They have cool cases too. They're Famicom cartridge cases. They're still going to be really cool and look really cool, but also, if anybody wants to send me a Famicom so that we can play with a Famicom too, you know, then maybe I can make a Famicom cart. No, but yeah, so this is coming. So this is why I'm skipping hardware for a little bit, because I'm gonna wait for this to come in, because I kind of need to. Otherwise, I'm gonna basically be cutting all the traces on the Mario Kart, and that is kind of stupid. But this should be in sometime next week, or maybe the week after. We'll see. In the meantime, we can mess with trying to figure out how DOS 65 works and various other things. But for now, let us attempt. I think I need to implement. Let's work towards what DOS 65 needs. And what DOS 65 needs is listed somewhere in here. Ooh, also good to know. Again, backing up a little bit, I don't know how you set up TEA start. I'm sure it's in here. But the Kim 1 has the TEA start all the way up at 2000. So that bodes well on us needing to put our TEA at like above 4000 or some silly thing. I was just going to look at, since I'm in here, where those TEA versus what your minimum RAM sizes are, and I don't think it's in this document, but I did see useful stuff, which is right here, which I will get back to. That was what I was looking for in the first place. This is the edit manual. Come on, give me that sweet, if your TEA is this, your memory needs to be this. Because one worry that I had about that is if our TEA is going to be so high, we might need even more RAM. But I mean, we have a pretty big address space to. I think Dave said the other day when he worked it out, it was like 48K of space. So we're probably fine. But where the heck was... Ugh, I'm never going to be able to find this now. TEA. Oh, no, it was this document. Here we go. Yes. So, for example, if your TEA starts at 2000, you are going to need at least 24K of memory. Now, here's the question. Is that 24K of... again, I'm just going to ask this and then I'm going to move on because it's not important right now. And plus, I'm sure I can meet these memory requirements. But is that 24K including that first unusable 2000 hex chunk? Or is that total RAM? Anyway, we'll figure that out when we get to it. So, anyway, back to what I was saying was useful and that I was actually looking for is this table. So, this has all of the... If we're going to angle towards getting DOS 65 working, these are the hardware routines we need to implement. And the main reason that I care about that is that it, for example, mainly for the floppy stuff. If I'm going to be messing with floppy commands today, I should really implement them in a way that reflects this so that they're easy to map. So, for example, home selected drive. I think we just use our reset routine. I think that's fine. Select drive. I guess we'll just do nothing. Actually, I wonder... No, there is a thing where you describe to how many disks your system has and whatnot, so we're always just going to have A. We're not going to have a second disk. Not right now, anyway. But more importantly, set track. I guess I'll write a set track routine. Set sector, I guess... Really, we'll probably just store the sector number somewhere. Set buffer address is interesting. I'll have to look into that, but we'll... I don't know. Well, no, we can implement that. And then read sector and write sector. So I'm going to pretty much implement these, I think, as required, because that way we can mess around with them and make sure they work without having DOS 65 on here, and we're going to want them anyway. And then they're there. And when we do DOS 65, they'll be the way that it expects them to be. So, home selected drive. Does this describe what needs to be done? Home selected drive. This routine causes the currently selected drive to immediately move to the home position, track 0, blah-de-blah. Okay, this one is fast and easy because we already have code that does that. I just need to see if it needs to be broken out. So, where was... We are all the way bottom. And this is the other thing, is if I can get to it today, or if not, we'll continue it next week, is taking all this code and breaking it out into separate buildable units so that this code is actually frickin' readable. Okay, we're close. We're close. We are looking for... I mean, there is this FDC select drive, so maybe that's what I will implement for select drive. I don't know. Anyway, also, I like how it had... this is going to be... Yeah, if we want to use DOS 65, we are probably going to be forced to use a 5 1/4 inch floppy, because I don't know if you just noticed, but one thing that occurred to me that I just noticed is there is no select head. Does it only support single-sided drives? Should we just write our own DOS? I don't know, man. Anyway, so where is FDC init? So this does a whole bunch of stuff, because it actually resets the whole floppy controller. You think I should just make FDC init the go to track 0 thing, because it resets the whole flippin' thing. I don't think having more than necessary in terms of resetting would be a bad thing. Yeah, because it does a chip reset and waits for the reset to clear, basically. We configure the whole thing, set the data rate, set the specify command. I guess, okay, we have FDC recalibrate. Maybe I'll just use FDC recalibrate, because that is really the one that I care about. So this is set. I think, were there any arguments to this? Because if not, I'll just rename this and move on with my life. Or maybe I'll just keep it the way it is, because the sim will basically just be a jump table to BIOS routines. Oh boy. So home selected drive, it has no return value requirements, no argument. So, and I believe they said we can fuck up the registers as much as we want, I think. So that one's fine. That one's fine. We'll just use recalibrate drive. We'll just call it that. That's fine. FDC recalibrate, rather. So moving on from that then, that's fine. I don't need to really do anything for that one. Select drive. Again. Like, does the select drive have to turn on the motor and everything? Because I already have code in here that does. FDC select drive. Right. And FDC to the select drive, did that turn on the motor and everything? Because if so, then that's another one that we are pretty much set. That's not true anymore. Yes, so that turns on the motor, waits for it to spin out, does all that good stuff. Okay, so we're set there. Again, let's scroll down and see what its requirements are for arguments. Select drive. Sets the drive for all following operations to the value of the A register, 0 up through 7. It is recommended that the drive not be physically selected until a home read or write command is received by sim. Ah, interesting. So that actually does slightly complicate things. I wonder if that's the same for like the track and sector set commands. That would be a thing that kind of makes sense. This routine must return a value that is the address of the disk control block. So that actually is fun and weird. The address must use the standard DOS65 convention, which places the low byte of the address in A and the high byte of the address in Y. If the selected drive is not present in the system, both A and Y should be set to 0. Okay, so that's an easy start. Right, so if we know, if we want to match their conventions and A should be the drive number, then if we're only supporting the first drive, then we can camp, compare A with a literal 0, and branch if it is not 0 to, let's call it FDC no such drive. Cool, and if not, then we turn on drive 0. All good. But then let us add FDC no such drive. And what do we do? Oh, wait, well, okay, so we still need to figure out that disk block info thing. Oh, I guess I should do that now rather than later. But the good thing is our code will just ignore that for now. But I should still implement it if it's relatively straightforward. But anyway, if we have no such drive, then I'll go ahead and load a literal 0. Transfer A to Y. So now they're both 0. And then return. Why do I always put return on its own line? That's just what I do. Because that's just who I am. Okay, and we should test this in a second, somehow. But that's the failure case. So if it does not drive 0, we say, sorry, champ. No such thing. Cool. Now what about this DCB? Where are DCBs described? Oh, right, and I forgot that whole thing about don't actually turn the drive on or anything until a read happens. Right. Wait. It is recommended the drive not be physically selected until a home read or write command is received by sim. Okay. Then how's about, I guess, using up more of them 0-page locations in a very unnecessary way. Let me just make a, what am I going to call this? I mean, here's the thing. It's really all this routine needs to do for DOS 65 purposes is return the drive select, or the disk description block, whatever that thing is called. Because if we do any floppy operations, we'll just select the drive at that time because we only have the one drive. Right? Does that make sense? So actually, let me do this. You know what we can do is, might be a good idea to have like the drive is already on flag somewhere so that we don't turn it on and wait for it twice when we do like multiple read sectors in a row and whatnot, because that would significantly slow things down. So yeah, let's just let's make a different, let's do FDC. Ugh, this is strange-ish. How about this? Because we're not writing this the sim code, SIM, the system information, or system whatever, the BIOS. We're not writing that actual code. We're writing the code that would call into and making sure that that is compatible with what that needs. So actually, I will implement that all in the SIM when we get there. And actually, that includes this whole compare thing and everything, because we should probably just do that in the SIM code, and then internally we'll use FDC select drive and whatnot to select the drive when we do commands. But not really necessary, because all that would do apparently, if it was called by DOS 65, is tell it, here's the description of the drive, which we can put in the SIM, and that's pretty much it. Or you're over 0. There is no drive. As for actual things that the FDC needs to do that we need to have support for in the BIOS, not really anything. So let's just get rid of this. And we will write the sim another day. So that changed not at all. Moving on. So that was select drive. Doesn't really actually do anything. Or there's nothing we need to implement for it. Set track. This routine should set the track for all the following disk I/O operation to the value in the A and Y registers. Which is funny, because even if we were using a high-density floppy, that don't go over 255 tracks. Anyway, the value will range from 0 to a number determined by PEM as a function of the DCB contents. This routine has no return value requirements. So pretty much seek to, I mean, I guess I'll just throw away Y. So not require Y, because we will never, ever, ever on our hardware need anything above 256 tracks. We will never need more than 80. So I'll just make it except A, and then when we write the actual sim, we'll just chuck Y out and just send A to the BIOS routine. And then the other thing I was wondering was, should this select the drive? Should we actually seek? I don't think we should actually seek. I don't think until we actually do a sector read we should do anything. This should just like set up what the next thing is gonna be. So there's a question actually is, if I'm not actually writing sim code, just code to support the sim, then should we just have a sector read command that takes track, sector, I guess not head. I guess head, and then we just will always pass in head 0 from the sim code whenever we get there. So yeah, that actually gives me a good direction. It's like, I don't actually need to implement this per se. We'll just remember in the sim code what track is going to be the next thing, and then when we do a sector read, we'll make sure we pass that track in. And then the sector read code will figure out if it needs to actually, like, seek. Is that reasonable? Is that reasonable? Is it? Or should we just seek? Anyway, how are you guys doing? Zach K said, I thought making my own logic gate CPU was a lot. This dude's making a BIOS for the NES. No, that's a lot more than this. Speaking from having played with that kind of thing before. Hey, Cliff Cheney. Hello, Fulololo. Redgeck says, hello, sir. This is not covered under our NES warranty. And Lawless says, hi. Okay, so trying to decide if I want to actually do a seek with the set track command. Okay, did we have like a seek command? There's the thing, is if we don't, let's implement a seek command, because, I mean, there you go. Seek, 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 seek. Here's the read sector thing. Does the seek happen inside of here? FDC read sector does not do the seek. FDC seek drive. So we have that. And right now it is seeking to a fixed address, I would assume. Now I have to look up this command again because I don't know which of these things is which. So let's go find out. Look back at the old documentation that we haven't seen in a while. Let's go to OS Dev because it's way better than trying to read that PDF. And where were the commands? Seek. So the seek command is OF. The first parameter byte is the head number, drive number. I guess that's fine. I don't know why we'd specify the head number. I don't know. Second parameter byte is the actual cylinder number. So, yeah, that's the important part. So I guess let's pass that in A, and we'll actually seek here. If it ends up being weird with DOS 65, then we can rejigger it later. But that's what I'm going to say is, let's just add an argument to seek drive. Let me make a note here. Seeks to track in A. And I shouldn't have to change anything about head and drive, I guess. And here, I guess what we can do is push A and then pull A here. Does that seem fine? Are we cool with that? Because that way we toss A on the stack, whatever was passed to us, and then we set up the FDC command. then pull that value back off the stack and send that for the seek. So there's one thing that we actually can test, and I will plug in the old floppy because it's fun to see if that's working on there. And we will seek to various tracks. In fact, I should be able to do that via the monitor too, so that might be fun. So what is the startup code doing? It is, here's a tent read sector. So it ints the FDC, selects the drive, doesn't seek at all. Is that a fact? Oh, does it seek an FDC in it? Or are we just not seeking at all because we were reading from track 0? That could do it and make sense. Blah, blah, blah. Here's that. Here's that. Here's the specify command. Yeah, no, we just like recalibrate and that's it. So let's do FDC init and then do a seek and see if our seek routine still works. And plug in the hardware floppy drive to see if it, does a thing that we would expect. Of course, it's not going to return us good data because it's a piece of shit, but we should at least see it seek if that thing works. And if it does, then we're all set there, and we have the necessary code for implementing the sim. So FDC select drive, and then I guess let's load a, I don't know, 20 and JSR FDC seek drive. There we go. And I should probably also make this do error checking, but let's just make sure it still works for the time being. And let's see what we get here. Let's see. All right. Burning a ROM, doing some stuff. Patrick Burke says, we got to seek a seek command. Damn right about that. Wait. Oh, damn it. Did it in the wrong order. Okay. Let's burn some shit. Load. 1000. Okay. Program. And while that is happening, let's switch to the old physical floppy drive. I know. Very exciting. Very exciting. Not that we have resolved anything with this drive, but I just want to see it seek, bro. And hopefully actually wire the power up correctly. Fingers crossed. Where is my 12 volts? It has run away. Okay, let's do the old stand it sideways deal. And I guess put a floppy in it to be destroyed. There we go. Good enough. And this is programmed, this is burnt. Let's move this over. Let me restart my video capture because that is probably screwed right now. One moment. Hi, there are two of me now. Or are there? I don't know if when I do that you guys see the extra camera feed. Anyway, yes, let's burn some shit. Redgeck. Now let's try to not actually physically burn some shit. Power on. Okay. Now, I guess turn it on. See what it does. It does braking. Neat. Super duper cool. What happened? Oh. I never put the lever down there. That would be a problem. There we go. And that could be track 20. I would believe it. Did it? Let's just double check. It says red sector, and that is almost certainly wrong. But I just want to check again, because, come on. I haven't messed with this in a while. 0200. Doot. Doot. Yeah, no. Just Garbo. But that's fine. That's not what I was checking. What I am checking is, if I reset this again, I wasn't really paying attention, but did it seek all the way out and then seek in a little bit? Because that's what it should be doing. No, it still appears to be all the way at track 0. Is what it looks like to me. Yeah, it never seeks back in. Well, that's annoying. I wonder why that is. It says red sector, though, so that just must mean that our seek command isn't working at all. Well, that's good, because we need to debug this, apparently. Oh, did anybody see anything obviously dumb about what I was doing? FDC seek drive. So we do select drive, and then we do seek drive. Is there anything wrong with this? Can I debug this? FDC seek drive. FDC seek drive. My God, FDC seek drive. There we go. So A should have 20 in it. Here's the question. We send a sense interrupt command. Sure we do. Wait, hold up. And then it just falls straight into FDC select drive. Okay, so that's... yeah, there should be a return somewhere in there. Maybe that's part of what our issue is. Though still, it should still be doing the seek drive and the seek command. Interesting. Here, let's do this. We're going to send the sense interrupt command, and it's supposed to send back the first 2 status registers, I believe. And at the very least, that should tell us if there was an issue or what the hell, why it didn't seek. Okay, so the first result byte is ST0, which includes basically did we fail or not. Whoops. And then the second byte is the cylinder that it thinks it is at. But what I'm going to do for now, for debugging purposes, is I am going to store this in, let's see. I have a thing for this. It is called ST0 result. And then I am going to store that cylinder thing in C result. And then I am, just to remind myself, going to put a JSR here so that we can actually get back to the caller, which is not a thing that we are doing right now. But before I do that, I'm just going to do a jump to the monitor, so that hopefully it should run that command, and if we look at what's in st0 result and c result, it might give us some idea of why it didn't seek or what the hell the problem is there. Yeah. Okay. Illegal addressing mode at 402. Yep, because that's a totally incorrect command. RTS, that's what I was looking for. And let me make sure I put a temp label on here. Temp remove, as is the way. Now link it. Now build it. Now assemble it. Cool. And back to this old chestnut. Back. Load. This. Okay. Program. Program. Redkick says, now that you marked it temp, it's there forever. You are probably correct. Probably. What did I title this episode? Something about cleaning up the BIOS code? Yeah. Yeah, about that. Anyway, this is programmed, right? I did program this. Did everybody? Hopefully I programmed this. I'll know because it shouldn't print red sector. Right? Yes? That seems right to me. Ah! Not my priceless floppy drive. I don't know why you would have a problem with the setup. It's perfect. There's nothing unstable about this. The only thing unstable in this situation is me. Puron. And you're gonna dump me into the monitor, right? Yes, there we go. All right, let's see what the heck those addresses are supposed to be. 1 second. I won't switch you back, but I'm just gonna look up where those locations were supposed to be. ST0 result is at 14, so 0014. That's 80, which I'm pretty sure means some kind of horrendous error. And 0017 is the cylinder. Interesting. Oh, well, because 80 means I'm not expecting you to be reading anything. Worm says, use a strong neodymium magnet to keep the drive from falling over. That's genius. So, yeah, clearly, it's like not ready at all. Like it's not expecting us to be making a sense interrupt command. This all just leads me to wondering if we are like not reading interrupts properly. Or like they're not cleared properly. Because that could be part of our issues. Because there's nothing about, let's see. Like this is all set up correctly, as far as I can tell by the way that it's spelled out in the whatchamadoozit. And we should get an IRQ. But here's the thing, is that this just waits for a flag to go high, and that's it. So what if that flag is already high, right? That's my concern. What if we have, like, what resets that flag? Let me see really quick if there is anything obvious on, because I feel like that might be a thing that has been biting us in the booty this whole time. I have been wondering about this a lot. I don't know that this is our issue, but the fact that I'm sending what is, as far as I can tell, a perfectly well-formed command, and the result is Garbo. No. hold. MDMA. What is the one? I mean, I could also possibly just check this command busy flag. That might be a better way to do it. I don't know if floppy seek has a result phase. I guess result phase is always the last thing that happens, so I would assume. But maybe that's what we should check. Though I mean, the fact that it doesn't even start to do the seek, though maybe just attempting to do another command aborts everything. Ugh, it's weird that it's not even trying to do a seek. It's annoying. It's confusing. What am I looking for? I'm still looking for, what the heck is that flag that I've been using? I guess let's look at the code. Let's look for wait FDC IRQ. Wait FDC IRQ. We load from the 0th register, which is status register A, which they apparently don't have a definition for in this document. Neat. Neat, neat, neat. I guess it is to the PDF we go. I do want to know more information about that. Where is it? Here 'tis. No, it's not. Here 'tis. Ooh, this seems like a much more responsive document than the other one I was looking at off BitSavers. Okay, so status register A. PS2 mode. Right, so I'm checking this interrupt pending bit, and what I want to know is when does that get cleared? How does that get cleared? It's used by software to monitor the state of the interrupt pin. The bits marked with a star reflect the state of the drive signals on the cable, independent of the invert pin. Int pending will be low after reset. Let me just do a search through this document for int pending. And it shows up twice. Uh-huh. So you know what I'm going to do? I am actually... this could be a bunch of my issues. I'm going to write another routine really quick, just for checksies. We're going to call it wait FDC command. And instead of checking that IRQ bit, I am going to check, not int pending, I am going to check, and it's gone. What was the name of that thing and its location? It was the end of stuff thing, command busy, which is bit 4 of the MSR. And the MSR is 4? I believe that's 4. So it's 4 of 4. Right? Yes? Main status register, yes, is 4. It is bit 4, main status register. Which means that would be, we would mask that with 1, 0. Read from 6804 and it with 1, 0. And then let's see. So BEQ is checking to see if it is 0. So if it is 0, we keep looping. If it's 1, right. So we may need to invert that. What did they say about it? Where are you? Main status register. Command busy. Set to a 1 when the command is in progress. This bit will go active after the command byte has been accepted and goes inactive at the end of the results phase. If there is no result phase, seek recalibrate commands. This bit is returned to a 0 at the last command byte. So that is annoying. So I actually cannot use that for seek. Good lord. Ah, wait. Drive and busy. These bits are set to 1s when a drive is in the seek portion of a command, including seeks and recalibrates. So I wonder. Let's check those when we're recalibrating, actually. Yeah, let's make a routine that checks to see if drive and busy are 1 and waits till they are not 1. That's always going to be drive 0 busy. Oh, drive X busy. Okay, sorry. But that's still... So yeah, we just need to check bit 0. So let's make wait FDC... Let's call wait FDC seek. Wait FDC seek check. Wait FDC seek check. And then that was still 6804, but now we swap this to 01. And again, now I have to think about it. So drive busy is going to be high during the seek, so we keep looping until it goes low. So it's going to be branch if not 0. There we go. Now let's use this in both our our seek and our recalibrate commands. So let me search for seek. FDC seek drive. Here we go. And I'm going to leave this just because it doesn't seem to be screwing anything up. But I'm going to add JSR FDC, no, wait FDC seek. Hopefully, maybe, that's good. Now, it also might be that I just have interrupts turned off, so it doesn't give a single shit about these. That is also a possibility. Maybe. But yeah, let's do this, because that would also screw up things for recalibration. So instead of, let's do the same thing for recalibrate and make sure that we actually wait for the drive to not be busy anymore after we recalibrate instead of just plowing forward, because that might also be screwing things up. JSR wait FDC seek. Cool. Let's try that one. Let's see if that makes things any better. Yes. And time check, it is 6:01, so we've got about a half an hour before I have to jet out of here. So that's cool and fun. Just FYI. Okay. YouTube in there. Programmer. Run this again for good luck. Load. Offset. Okay. Program. Beer. Back. And here we go. To see if there is any discernible difference. Oh. Disk in. I don't know why I took this out. It's because I'm losing my mind. Which is impressive that I had any mind left to lose in the first place. And here we go. Yeah, like, it didn't even attempt to seek yet again. The frickety frack. What the frickety frack? Don't talk back. So it's like the seek command isn't even being done at all. I mean, I also wonder if we're, like, beginning to read that bit too soon? That seems silly. Why are you not even trying to seek? Why? Why? Oh, let's look at a thing, because it should have... You know what, before I do the sense interrupt, I'm actually going to... Let's see. Let's do wait. We'll send the command, then we'll do wait FDC seek, and then I want to read the status registers to see like what the state of the thing is in right after I send this command, because maybe that will shed some light on things. I don't know. It's like it seems to be just rejecting the fact that we're trying to send a command at all. Let me make sure that seek drive command is actually correct. The weird and annoying thing is that we sook this drive before. FDC, what am I doing? OS dev. Floppy disk controller. And it was seek. Yeah, 0F. That's it. It's possible to use the disk active bits in the MSR. Yep, that's what we're doing. And I also hope that I'm sending sense interrupt commands everywhere that I need to, because that could be screwing things up. Okay, so anyway. Sure. I don't know. I'm throwing shit at the wall now. Wait for the seek, then go to the monitor, and then let's just look at what is in the status registers. Yeah, Trey said seek, then drop to the monitor so you can poke at it. Yup. Here's something interesting I thought about after participating in a previous stream. Once you get the diskette drive working, you're only a step or two away from MFM hard disks. Ooh, I don't own any. I feel like they're probably expensive to get a hold of right now, but you're not wrong. Worm says, but the FDC send command checks the MSR first, does it? I feel like I've asked this before and you confirmed, but I don't remember. It damn well is supposed to be. We can look really quick if you want. And Trey says, I don't think you have enough browser tabs open. You're damn right, Trey. But yeah, let's look for Udly doodly do FDC send FDC send. Really? What is it actually called? Send FDC command. Send FDC command. Here we are. So it does a bunch of stuff, does a bunch of stuff, does a bunch of stuff, and what even was this about? Because this is my whole bunch of error checking, and we're doing a loop to check to see a thing. Oh, this is all loop setup, right? So then it goes to actually send the command, or yeah, send the command, and yeah, that's the top of the loop. Loads from the MSR, checks to see if the top 2 bits are. Oh, you know what? That's actually something that I might want to check really quick. Is this just timing out? Because it might just be timing out. It might not be ready for us to send a command. That's a possibility. But yeah, so we and the top 2 bits of the MSR, and the top 2 bits are MSR, RQM, and DIO. RQM should be 1 because it should be saying we want to transfer, and DIO is saying the direction, and 0 is a write. So yeah, we check 80. So indeed, but yes, I'm never actually checking the result value which should be a 1. Oh, wait, actually. I forgot about this. Hold up. I wonder if it's jumping into the monitor here. That's a thing I hadn't considered. Let's check that really quick. Is this still on? Because that should be real easy to figure out. Are we not in the monitor because it got through all the seat code? Are we just here because we had a send command error? I forgot that debug code was in there, so that is useful. Let's see, where is that 0 page value for stack pointer? SP value is at 1B. 1B. So there's nothing on the stack? Is that what you're telling me? Really? That can't be right. I mean, I guess it means it was just never initialized. That's probably what that means. And that subsequently, we did not have a command timeout failure. So, there's a thing. AIO Incorporated said on the topic of the MFM hard drives, they're actually very cheap on eBay. The ST506 ST412 is really simple and only a few more control lines than the 34-pin floppy controller, mostly to deal with extra heads. And AIO said, do you have a Discord somewhere? Yes, I do. Yes, I do. Let me drop that in. We had a few good people pile in the other day, so let's keep that party going. Invite people. Copy, copy, copy. I'll tell you, progress is slow. There's the Discord link. But I do post updates on there, so. Anyway, that just makes things even weirder. So I guess we'll just go back to the original plan here, which is bail out after sending the seat command and see what kind of state the controller is in. FDC CEEC drive. Okay, no, we already finished that, so we're here. Excellent. Very good. And cool. And let's program that. And let's turn off the power. And yeah. Last little push before I have to bail in about 15 minutes. I guess we're not cleaning up code today, you guys. Oh, whoops. I guess we're not cleaning up code because I can't even get past implementing the seat command, which was working. That's the pisser. What am I doing? Clearly, this is why I need to stop streaming and go play tabletop games. Program. Back. Table. Flippy-do. Insert-y-do. And I'm just going to dump all the registers and look at them and go, and then leave. Here we go. Okay. So I also enjoy that something is probably not right with the wait for the drive busy to not be high no more function, because that prompt definitely popped up before it was done seeking to home. Let me just confirm that. They were very close, but I do think that prompt came up before it was done seeking. Maybe not. maybe not. Those might have been simultaneous. Hard to tell. This is why we need a copy on GitHub. Yeah, let's do that before I take off, actually, because that will be easy. And I have already made a Git repo locally, so I will commit, and I will create a repo, and I will push it before I go. But anyway, before we do that, let's just dump all the registers. Let's see. I pull up the list, and then I will go through them. And we shall ponder on their contents and go, yes, very interesting. This tells us nothing. Okay, starting at status register A. Yeah, these are in order. And PS2 mode. And sorry, you won't be able to watch. But let us do 6800 and let me see. I'm just going to dump them all and then refer back to this because there are only so many of them that you can read from. 6801 is status register B. Then we have digital output register at 6802. These values seem weird. Then we have tape drive register at 6803. 6803. Am I doing something horribly wrong? It feels like I'm doing something horribly wrong. Those don't seem... Anyway, let's just keep going. Main status register is at 6804. 6804. I get more suspicious every single time I hit a button. What's the next one? The data FIFO, no need to dump that. And the digital input register, which isn't going to tell me much. That's at 6807. Theoretically. So what are the odds that every single one of those would be 80? I'm thinking those odds are real low. And I'm wondering if I'm doing something very stupid and wrong here. What would it be, though? What would it be? Let's do a quick sanity check. Let's just see what's at the zero page register or zero page value. No. So either things are real screwed with these registers, or they just happen to all be 80. Well, let's see if that makes sense at all, which it probably doesn't. Status register A, a bit in that position would be interrupt pending. And then, let's see, the next one, so all the rest are low. And those are indicating signals coming in from the floppy drive. So the next one below interrupt pending is, it doesn't say. It actually really kind of doesn't. I mean, it's listed on here, but it doesn't really say what it is. It's the inverted drive 2 signal, which I don't know what that is, but if it's 0, it's asserted, so it's asserted. Then there is step, which is not inverted, so it's not stepping. There's the track 0 indicator, which is 0 if we're at track 0, so that would be fine. And head select, which we are selecting head 0, so. Index, which one would think would change regularly, because I think that's the index pulse, but whatever, that is also an inverted signal, so you would expect that to be high. Let me just also make sure I'm actually reading from the right addresses. Show me code. Show me where I'm supposed to be reading from. Yeah, no. My addresses are 68 blah-de-blah. Inverted drive 2 signal is the control to select the second drive on the twisted ribbon cable. Yeah, that's kind of what I thought. So if that's active, it would be selecting drive 2, which, no, we're not selecting drive 2. So something is super, super fudgy here. What the frick is going on with my registers? I'm kind of at a loss. So we may just be cutting it off here. This has been a very annoying month. There's no way those are all just 80. Those signals don't even make any frickin' sense. Let's look at, what was 6801? Status register B? I bet that makes even less sense. Status register B. In status register B, the first 2 bits should always be on. So, yeah, that's wrong. That would be a C at least. You're not selecting the drive 2, I don't think. It's inverted, is it not? Right, it's a 0 in that position. In that first 80, that is the second to most significant bit in there. So if it's a 0, that means that the drive 2 line is asserted, which it shouldn't be, which tells me that these are garbage for some reason. Redgex says, could be a bad physical connection, and I'm thinking, yeah, but at the same time, like, the recalibrate command is sending and executing correctly, so what the fuck? AO says, index should just be for the index position of the diskette. It will only change when the disk is spinning. Right. So I would expect it to generally not be asserted. Wareham says, maybe the FDC reset is not working? Yeah. That's pretty much what's on my mind. I don't know. I haven't seen this much garbage out of this thing. Like, it's gotta be a physical connection. It's so screwed up. It's so screwed up. Let me, just for fun, do this again. And then I gotta get out of here. I got 10 minutes. So we will put this on GitHub, and you guys can tell me how screwed up it is. Or have thoughts. You know what? Just for fun, I'm going to turn these both on at the exact same time. Well. That was weird. Wereworm, we might be onto something. We might indeed be onto something. See the way that it's sooked when I turn them on at the same time? Because maybe we have frickin' voltage bleed that's screwing things up? Maybe? Could be. This is interesting. But it's reliable. You see that? Are you able to see that on the webcam? What if this explains literally frickin' everything about what we have going on here? What if? You know what would be fun, actually? Ooh. I wanna try sending a seek command from the monitor, but I have no way of guaranteeing what's in the A register. AIO Incorporated said, is the ground connected between them properly? Yeah, I mean, there's tons of ground lines that go between the two of these, so they should be. But I'm wondering, because Wereworm was pointing this out long, long ago, and I was like, yeah, could be issues, but this, to me, kind of seals it, is if I power this drive on and let it come on way before the Nintendo, and then do this, it does not do the reseek thing. Or the reseek, just the regular seek. It doesn't seek. But let's see. Okay. I'm going to do that just to not have it in a different, more interesting position. That's what I'm going for. I want to power this on. So simultaneously, seeked perfectly, seeked just fine, seeked beautifully. So yeah. This makes me really, really, really freaking want read a sector on this thing, because if that is literally the entire problem, oh, I'll be happy. Okay, I know. I was promising other things, but damn it, I really need to see if I can read a sector off this damn thing, which should be pretty easy, because I just need to skip over that seek command. Wherever it was. Seek. Yeah, here we go. So just comment that out so that we don't do it at all. And let it do its thing. Because that would be fucking sick. Hold up. I need to write a floppy image. I will be right back. This will be fast. The computer's even on. It's ready to go. But I'm not going to move you over there because we have 0 time. I'm back. Also, I wonder if that can explain why our discs keep getting fucked up, right? Yeah. I was wondering very similar things, Wereworm, in that, like, I kind of started assuming at some point that, yes, the drive activity on power-up is probably because the signals are in all kinds of places. Yeah. In fact, I'd assume probably, if anything, we would probably want to turn on the machine before the floppy. And then, anyway, normally they're both connected to the same power supply, so, yeah. Right. Wait. Hold. I'm getting ahead of myself. This was fixed. We need to build it. We need to program it. I'm going to be pissed if this works right. Actually, I'm not. I'm going to be cella-fucking-braiding. And we can throw the Gotek in the trash where it belongs. It's no good for anything, and everybody hates it. Nobody ever wanted it in the first place. Tom is giving me a 4-minute countdown. Yes, sir. Yes, sir. I might just be about to solve some shit, though. So, yeah. And Redgux said, be advised, whistling out of frame is how you die in movies. Is it? I feel like whistling out of frame is like the person casually killing the other person because they're a psycho, and they're the one whistling. Tom says, your chat is going to hate me since I keep ending your streams. No, they were warned. They were warned. I actually warned them this time, like a good internet citizen. In you go. Oh man, I am tingling. All right, floppy. In. But yeah, I don't know if I finished that thought. What if that's why our floppies keep getting screwed up? Because it's like trying to, like it's activating the head and trying to write nothing garbage to it. Because of, yeah. So anyway, here we go. Prepare to be disappointed. Huh? Yes. 0200. Okay, that ain't right, but at least it's interesting. And different. I'm going to try it again. Real quick. And then I'm going to go check to see if the floppy data is all screwy, and I will let you know. And then I'm going to piss off. And I will get this on GitHub. I will do it off camera. I will drop the GitHub link in the Discord. It is consistent, though, which is interesting. Looks mostly consistent. Huh. Fascinating. Okay, I'm going to go verify this disk. That wasn't as exciting as I hoped, but also I said it probably wasn't going to work. Yeah, all right. I'm going to go read this. Here goes the whistling again. I can sit here while it's doing that. Tom says 0 minutes. Tom, get bent. I don't mean that. I need to confirm this, and then I'm getting off stream. Tom says we're gonna kill you off. That's probably the fact that I haven't died already. It's pretty impressive, given the way I've been playing this game of ours. Okay, disk is red. Let me do the things now. I am catting it to a hex file. I am vying the hex file. Nope, this disk is fine. Doesn't have garbage data on it. Totally fine. So, that just didn't work. Just didn't work at all. But I'm curious about that seek thing, and that tells me I think our seek code is fine. This is just a piece of garbage shit. And by that, I just mean it's not starting up simultaneously. Maybe I should figure out how to just power the NES off of this supply. One second. I do need to go. I think it's literally 9 volts, but if it can go up to 12, that would be sick if I could just power it off of there. This outputs DC 10 volts. So I don't know what that can withstand. It's currently running off a 9 volt guitar pedal cable. But if we can just run it off of this supply, that would be dope and maybe solve some of our problems. Anyway, peace out, because Tom said, I guess Redgex's advice was true. You do die when whistling off camera. Okay, so I need to get out of here. AIO Incorporated says it has a 7805 regulator inside, so yeah, 12 volts is probably totally within spec. Well, we'll be able to find out next time. But that tells me, Seek works, we'll figure out the rest, we'll figure out why read sector isn't working on a real floppy. But I didn't want to do that. I just wanted to make sure I had a working Seek command for the DOS purposes. Okay, see ya, love ya. I will get that thing on GitHub. I will drop it in the Discord. Bye.